JKube. So the plan for today is talk a little bit about JKube. We will be hosting this, myself and my peer Rohan. So I'm Nuri. I'm working as a software developer for Red Hat, and we're currently maintaining the Eclipse JKube and the Fabricate Kubernetes client. Rohan, you can go ahead and introduce yourself if you want.
Hi guys, I'm Rohan, and I also work in Red Hat as a software engineer, and I've been working on Eclipse JKube and Fabricate Kubernetes client, basically around making Java developers experience good on top of Kubernetes and OpenShift. So yeah, that's pretty much it. I'm very excited to be here.
Okay, so let's talk about what JKube is, or what we're trying to do here. So for some of you, maybe you already know the Fabricate Maven plugin. JKube is the legacy of this plugin. It's the rebranded version of the Fabricate Maven plugin, and basically what it is a set of tools that will help you build container images and deploy these images into Kubernetes or into a Kubernetes flavored cluster. So the main difference with the Fabricate Maven plugin is that we've extracted the core logic and functionality of the plugin into a separate library, which is called JKube Kit. And then we provide a set of, well, mainly right now we only provide the plugins, Maven plugins, but the idea and the feature is that we will be providing additional Gradle plugins or other developer tools that will help you use JKube in your projects. So Rohan, do you want to explain a little bit what each of the plugins does and what the main differences are?
Yeah, earlier we had just one plugin, Fabricate Maven plugin, which used to work for both Kubernetes and OpenShift. It also had some bindings to the Fabricate.io platform, which was a platform for deploying your applications, but it didn't work out, and the project had to be closed. But Fabricate Maven plugin is being used by so many people, so we, as the maintainers of the plugin, we thought that we can maybe make these general purpose Kubernetes or OpenShift plugins which can be used by many people. So now what we have here is they are purely clean plugins which provide pretty much the same flow as the Fabricate plugin, but without any dependency on the Fabricate.io or any legacy framework. So it's the same old stuff, but in a rebranded and repolished way. That's it.
Okay, great. So, well, this was not planned like a presentation, or it's more like an interactive session. So, what we're planning to do is start with a short demo of how you can use the plugin in your projects right now, and then when we're finished with the demo, what we want is that you actually ask questions and maybe request another demo for a framework of your choice if it's supported by the plugin, and so on. So we will be starting by this by demonstrating how to deploy the Quarkus to-do list application into Kubernetes. So this is something that Rohan blogged about like 3 days ago, and it had quite a good acceptance. So I think it's a good idea that we do this live. So maybe basically what we are going to do is we are going to clone the Quarkus to-do app that was deployed by Clement Escoffier into Minikube. So basically, it's just you will see that we don't need that much configuration, since the plugin will automatically infer most of the configurations. The only configuration that's needed is to deploy the PostgreSQL database. But again, this is something that's going to be quite trivial, since we are going to use the resource fragments and this functionality that it's already provided by JKube. So Rohan, if you want to go ahead and share your share your screen and start with the demonstration. Rohan will start demonstrating this on Minikube, and then I will pick it up and demonstrate the same thing with OpenShift.
All right, let me share my screen. Right, can you see my screen?
Okay, okay, so I'm second.
No?
Yeah, I can see it, but I cannot. Okay, now. So now it's pinned.
All right, guys, so here I am. I have already the sample clone, so it's a very basic Quarkus application which has this to-do endpoint, which depends on a Postgres database, which simply stores your to-do list into a table and tries to fetch it. So I haven't done much change in the project. So what I have done here is I have added some resource fragments since this application depends on Postgres. So I have added resource fragments for Postgres deployment, Postgres service, and Postgres config map. You don't have to worry about the details here because JKube is going to take care of all of that. So let's go ahead and let's try to deploy this application to Kubernetes, and let's see that how it goes. So let me stop sharing this screen and let me share my terminal screen. Wait. All right, guys. Can you see my terminal?
Yep.
So here I am. I have Minikube running. So I also have exported my Minikube's Docker daemon to my shell, so I can access Minikube's Docker daemon via Docker. So I'll go ahead and first compile this application. All right. So once the application is compiled, I'll just do KTS build, KTS resource, KTS apply. What it's going to do is it's going to issue 3 specific goals for Kubernetes Maven plugin. First one would build the Docker image for you. Second one is going to create the resource manifests. The third one is going to apply those manifests on top of Kubernetes. So let me go ahead and hit this goal. As you can see, it has created some pods. All right, so looks like it has finished. Let me check the pods. All right, they seem to be running fine. So let me go ahead and open it. Okay, I have to share my browser screen now. Sorry. All right, can you see my Firefox?
Yep.
All right, so here I have my application running inside Kubernetes. So I have exposed my service to a type of node port using JKube's property. So let me try to just do something, add some to-do list, like make tea, have dinner, sleep, I mean anything, and let me try to mark something as completed. So here I can see it's all working fine. So you can see how I deployed this simple to-do list application to Kubernetes without having to do anything related to Kubernetes, just using JKube. So, and all of this I did within few seconds. So this is the power of JKube. You can deploy almost any app to Kubernetes using our JKube tooling. So let me stop this and let me go back to my terminal. Okay, so now you have application running, and now I want to undeploy it. So I'll just do mvn-kts undeploy, and it's going to simply clean up whatever was created during the apply phase. As you can see, it has deleted all the resources it created during the apply phase. So this pretty much covers the demo. Mark, do you think I should showcase something else too?
Okay, I can showcase now the same thing for
Okay.
Quarkus, and maybe next we can do it for the native image if you can. But let me. I'm going to repeat the same process, but now from the beginning. Okay. Okay, you can see my screen right now. Okay, right?
Yeah, I can see it.
Okay, so I'm. You already did some of the process, but I'm going to do it now from scratch, so we can actually see that it's like really easy, even with a different cluster or a different configuration. So let me go ahead and clone the project.
Could you please increase the font size?
Yeah, please. Sorry. Okay. So okay, this is the project as it comes from GitHub. No alterations. There's nothing. There's no JKube here yet. So let me open it in the IDE. Okay. So the project is still being imported. Okay. So the font is right. Okay. Is it okay to see it like this, Rohan?
Yeah, it's fine.
Okay. So basically, this is a Quarkus project. It's based on an older version of Quarkus, but it's going to work either way. So this is also something good of JKube, that maybe you have an older version of a project which a project which depends on an older version of Quarkus, which doesn't provide as many things as maybe the latest release, or maybe you are blocked in your company and you can't upgrade. But when using JKube, this is not a problem. So what I'm going to do is just go ahead and add the OpenShift middle plugin. So this is, if we were not going to need the database, this would be enough just to deploy this project. We could even run these Maven goals from the command line without even adding the plugin, but that's something else. But anyway, we actually need well, if you check this README here, well, there's not much documentation, but basically what you also need, you need to, as a prerequisite, you need to run the database. So this example is supposed to be running on your local machine. We're going to run this in the cluster. So in order to deploy the PostgreSQL database, Rohan already showed you that we have like a special directory that JKube will recognize. So in source main JKube, you can add here resource fragments that will be processed by JKube and maybe enriched. So we really don't want these fragments to get enriched or to get altered, because we are already going to provide everything that's needed in order to deploy this database. So we are going to go ahead and put them below this directory, this raw directory, which means that they won't be processed. This is some special profile in JKube, but you don't need to worry about this. But basically, if you place your resource fragments below JKube, they will be enriched. If you place them here, they won't. So for the PostgreSQL, we are going to create a deployment. So okay. And I have here what's needed. Okay, so this is basically a deployment descriptor, which contains the Postgres image and a few environment variables that are going to be needed by the project. So we are going to define the user, the password, and also the database that we are going to be working on. Next, we are going to define a service to expose the pods that will be created by this deployment. So Postgres. Okay. Again, this is a simple service, and it's just going to expose the default PostgreSQL port, which is 5432. And finally, we need to modify a little bit the properties for our application. So the application is expecting the database to be located in the local host, but this is not going to be possible because it will be in a different pod and in a different container. So here, what we're going to add is the name of the service. So Postgres. And again, we must make sure that these values match the ones that we provided in the configuration. So the database is okay, but the users and the password ain't. So here we're going to replace this and this, and that shall be it. As I said, I'm going to deploy this in a Kubernetes cluster, in an OpenShift cluster. So I'm going to use, well, this is an old cluster, but this is a remote cluster. It's not in my laptop. And let's get started. Okay, so I'm going to file a project. Okay, the project has now compiled. So now what we are going to do is we are going to build the container image. In this case, since we are targeting an OpenShift cluster, we are going to use the OC build goal. This will detect that this is going to run in an OpenShift cluster, and it will perform an S2I binary build in the cluster. So let me go ahead. Oh, a second. Okay, let me switch to my OpenShift cluster. Okay. The build should appear here whenever it starts. So let's wait. Okay, as you can see, the OpenShift cluster was detected. We are starting the build with an S2I strategy. And this is the build that's starting. Okay, so the build completed successfully. We can see it both here and in the results of the Maven execution. What we are now going to do is we are going to create the resource fragment, the cluster configuration resources, the YAML files that will be used to deploy our application. Again, JKube provides this resource goal that will be in charge of doing this. These resources will be placed in this directory, JKube OpenShift. So this is what JKube created for us. So this is the fragments that we provided for the Postgres database. So this has not been altered. This is the original fragment that's located here. Then it created a service for us. So here you can see that we added many annotations based on the JKube defaults, like the git commit, the branch, etc. We also added labels based on the enricher on the label enricher from JKube, which adds the name of the application, the group, the version. And then the specs. These are inferred from Quarkus. So there is a Quarkus enricher that will add this port, which is the one that Quarkus is exposed. It will also add this deployment configuration. And again, well, this one is the one for the database. So as you can see, it's exact same content as the one we provided in the fragment. It's not been altered since it's in this raw directory. And also, since we are using OpenShift, it will create a deployment config because it's specific for OpenShift. And again, with everything has been inferred for us, all of the configurations, the name of the image, etc. So we really did nothing for this. Finally, since again it detected an OpenShift cluster, it creates a route for us. So the service will be automatically be exposed and publicly available. So now it's the moment that we can apply these resources. Again, we offer this goal that will do this for us. So if we go again to the OpenShift web console, we should see this is the pod for our build, but we should see a similar pod coming up as soon as the deployment is ready. So this is the pod for the database that was created with the fragment that we provided, and this is the pod for our application. So if everything went fine, we should be able also to see a route here for the application. If we click here, it seems that the application got deployed. Let's see if the database is working. Hello. Yeah. So you can see that the application is working normally. Let's check the logs for the database, see if things are getting persisted there. Yeah, so the database started and everything seems to be working fine. The roles and everything was created by the to-do application. So everything is working as expected. Same as with the Kubernetes Maven plugin, we provide this other goal to undeploy. So this should get rid of all of the resources that we generated in the cluster. Okay, Rohan, I see that you're back. I think you had some power cuts. Was it solved? Okay, let's check. But yeah, the resources have been deleted, so there is no trace of our application. Even the build should have been deleted, so there's nothing left here. Rohan, are you there? I think you're frozen. Yeah.
Am I audible?
Yeah.
Yeah. What was your question?
No, if you are available again, or you're still with the power cut issue.
No, it's back now. I'm available.
Okay, so yeah, I just demoed the same to-do app Quarkus application in OpenShift. Do you want to do the demo for the native image?
All right, let me do the demo of a native image. So let me go ahead and share my screen again. Okay, there is an option for sharing entire screen. Let me go ahead and share entire screen. So please let me know whenever you are able to see the screen. Okay.
Okay, let me pin it. Okay. So you just restarted your machine, or is this?
Yeah, I restarted my machine. Sorry for that.
No, but it's good because we will see that JKube is actually really easy to start, and it doesn't require anything special. So.
Okay, can you see my screen?
Yeah.
Can you see in the terminal?
Yeah.
So now I'm going to demo the Quarkus native image mode. So what it does is it tries to create a native binary which can be executed using the Quarkus Maven plugin. So I have this profile here with the native profile, and it does a Docker build for creating the native image. So right now, Quarkus Maven plugin doesn't work with remote Docker daemon, so I would need to be connected to my local Docker daemon. So right now, I am with my local Docker daemon. So in order to do the native build and create a native executable, I'm going to do mv clean install p native, and it's going to do the native build.
Let me interrupt here. Sorry.
Okay.
You can actually create the native image if you have Graal in your system. So if you had Graal available in your system, you wouldn't need this Docker build. So it would use Graal directly. So this is because we are using, or Quarkus is using Docker to spin up a container that will perform the build using Graal within the Docker container.
Yeah, thanks a lot for covering this. So now you can see it's trying to pull the image for doing the native build, and let's wait for it to finish because Quarkus native build takes lots of time because it it shifts all the startup time to the build time. So let's see how it goes.
Yeah, it's kind of a pain for demos because it takes longer, but in real life applications, it's really useful that all of this time that that you spend during runtime to spin up your application, it moves it to the build time. So basically, the application whenever you deploy it, it will start up in a few seconds, right, Rohan?
Yeah, right.
Yeah, so now it's spinning up this container to perform the build with the Graal options.
Right. I think it has started the build, right?
Yeah. Okay, it should be finished any minute now.
Okay.
It's cool because this application is also using Hibernate and other dependencies. It's not just like a simple Hello World application. So we can actually get to see how Quarkus interacts with a database and so on.
Yeah, right. I really like this because we are not showcasing the Hello World app because it's too boring to demo. Everyone can get anything working on Kubernetes with just a Hello World application, but when it comes to running a database, providing microservice that interacts with database and lots of things, I think this is a general use case that Java users can relate to. So I think it's good. I don't know when it's going to finish. So this is the native mode for you. It's
Also, as we saw in the previous demo, this is running an older version of Quarkus. So some of these warnings will also be gone. I don't know what Java version are you running in your machine, Rohan?
on my machine. Let me check. It's
Okay.
1.8.
Yeah, one of the warnings comes because you're not running Java 11, but
Okay. Let's wait for it to finish. We can talk about anything else.
yeah, maybe you can show us the POM file to see exactly what configurations were necessary for this to work. Besides, so I know that there is like the profile for this native profile.
Yes, as you can see here. Yeah.
But regarding JKube, the only specific configuration we added was this native image flag, right? There's nothing else.
Yeah, I was going to come to that whenever this finishes, but let me go through this here. Wait. So as you can see here, this is the native profile which would be triggered when we build with native mode. And regarding JKube, we only need to tell the JKube generator that you use the native image mode whenever you are building the image for Quarkus native app. So this is the only configuration I have done for native image. And so have you talked about JKube's generator and enricher? I mean, in your demo?
No, maybe it's a good time for you to introduce these concepts.
Yeah. So Eclipse JKube right now, it does two things. three things for you: build the image, generate Kubernetes manifests, and apply them to the cluster. Applying them to the cluster is very simple as just applying the YAML. So the interesting parts are generating those manifests and generating the image. For generating the image, JKube has this concept of generators where it tries to build up an opinionated image configuration for your application just by looking at your plugin dependencies and other things. So, and enrichers are something that are used for generating Kubernetes manifests. So Eclipse JKube would check whatever things there are in your project, and it would build up the YAML for applying to Kubernetes with the specified health checks and readiness and liveness probes. So these are an overview of generators and enrichers. What I'm using here is a generator. So this flag would come into picture when Eclipse JKube is trying to build an image for your application, and it would see that native image flag is set to true, and it's going to use the native image mode for that. Simply, I think it could change the base image of your application for native image. So let's check whether the build was complete or not. No, it's still not
Oh man.
complete. Do you want to add something on this?
Well, for the again, we provide this, or JKube provides these default generators and enrichers. So depending on your framework, your project depends on, or a few other things, it will basically infer any configuration it needs. So for the generator, it will choose the base image for you. It will select the ports. It will select a few things, and create this image configuration that will be used to build your container image. Then again, this generator is good because it's something abstract. So JKube provides several ways to build your image. You've seen already the Docker build and the S2I build that was built in the cluster, but we also provide a JIP build. So it's regardless of the generator that comes into play or your project or anything else, everything will work out of the box with either Docker, S2I, or JIP. So this is really great. And then regarding the enrichers, again, we provide enrichers for many things. You saw, like, we were adding labels for the Git commit, the Git branch. The service is generated with, depending on the port that your application is exposed on. Many different things, but we also provide enrichers for different frameworks. So you've seen Quarkus right now, but then we also have Spring, Vertex, and I don't know, any other web application, containerized web application, etc. So we also are looking forward for contributions, either in the way of pull requests or issues of people requesting support for other frameworks, etc. So I think it's a great project to have or to depend on in order to make your application cloud native, because it basically will do most of the stuff for you. And as you've seen, we really don't need to provide any configuration, because everything is inferred from your project, or very little configuration, such as configuration flags, like in this case, if we want the image to be native, because this is something that it's specific for this. This project can neither be native or based on the Java virtual machine. So yeah, very little configuration. I think that the build already finished.
Yeah, right. So
Okay.
thanks a lot for your detailed explanation, Mark. So as you can see, the native build has finished, and it created an executable here. So let me just try to execute it. Target to backend. Oh,
You're missing
sorry.
the runner. Yeah. You don't have
Okay,
the
so
database
I
in your system.
I
So
don't have the database, so it's not going to work here. So let me go ahead and deploy this application to Kubernetes.
It's actually kind of, I think that it's cool that we've seen this, because for you, it's going to be easier to deploy this into a cluster than deploying it in your local machine, because you don't have the requirements. So we saw on the project README that you require this database, you require to run some Docker commands. You may don't even have Docker in your system. So I think that this is really, really cool, right?
Yeah, definitely. So what I have done here is, so I have pointed my application's data source URL to a service which would be running in Kubernetes with the name Postgres service. So whenever you are using Kubernetes services, when you create one service, the information related to that service gets exposed to your running pods uh, with the environment variables. So when the Postgres service is running, it would be exposed to all the pods in that namespace with this environment variable Postgres service host. There are other environment variables also, which like port and full IP. So we would be using that this environment variable to connect to Postgres instance. As you already saw in the previous demo, that I have these fragments in my JKube raw directory, which will be applied during the resource phase. So let me go ahead and deploy this application. So till now I was using my local daemon. So in order to build the image again, I'll be using my Minikube daemon. For that, I'll do Minikube docker env. I'm going to simply copy paste this. Let me check if it's pointing to, all right, it's pointing to the Kubernetes daemon now. So in order to build the image, I'll just do mvn latest build. As you can see, it's pulling this binary image. Oh, I'm sorry.
No.
I forgot to add the native flag. So that uh, property would only be enabled when I'm using the native profile.
So again, just by adding this native profile, we see that JKube will actually select a different base image. In this case, the UBI minimal.
Right.
So this is really cool.
All right, so it looks like the image has been built. Let me check. All right, looks like it was built 10 seconds ago. So let me go ahead and generate. So if I try to run this image, I would be able to run it. But since there is no database, it would be giving the same error. So let me go ahead and create the resource manifest, which would be opinionated with JKube using the creators resource goal.
Could you unmaximize your screen, because lots of the text we cannot see what you write because our heads are on top of it. Okay, that's great.
Is it fine now?
Yeah, better.
All right, so I just ran the resource goal, and you can see it created a resource manifest for you. So as you can see, it copied all those Postgres related manifests directly, and it created this deployment with the image which we created. As you can see, this image was created by the build goal, and it generated an opinionated image for you, opinionated manifest for you. And just like that, it also created the service which would be exposing this deployment. So let me go ahead and apply this using the mkts apply or Or you can also use ambient creators deploy goal. Deploy this to Kubernetes. All right, let me check if my pods are running. Okay, so the pod has crashed. Maybe because the Postgres instance is
Okay,
hasn't come up yet.
it started after the Quarkus application.
Let's wait. I think it should be back in running state. All right, so it's
Yeah.
running now. So as you can see, so just after the deploy phase, all of these resources are created. Postgres is also running as a deployment. Your to-do backend application is running as deployment, and it created services for your backend application and Postgres instance. So all of these services are created with node type node port because I have explicitly set a property in my POM that please JKube create a service of type node port. If you don't specify this property, service would be created with type cluster IP. So now that everything is running and ready, let me go ahead and try to access my application using Minikube service to do backend. Alright, so as you can see, the application is up now. Let me try to have some to-do tasks. Mm, review PRs, make dinner, go call running, and let me try to some completed selected tasks, completed tasks. It's running fine as expected. So you can see that how I deployed this simple application using the plugin without providing any configuration. No dev file, no uh, no binary file to do stuff for you. Just plain old Java workflow, just plain old Maven tool by just adding Kubernetes and Eclipse JKube's Kubernetes Maven plugin. You can also go ahead and check for your application logs using the ambient creators log goal. It's going to show logs for your application, which is running inside Kubernetes.
Yeah, there are, since we are deploying the Postgres application too, this is not working as expected.
Okay.
This is something we need to fix.
Okay, this is not good.
No, so yeah, no worries. I mean, this is because we are providing the deployment information for the YAML configurations for Postgres together with the application. Probably this isn't the regular use case because your database will probably already be running in your cluster. But anyway, this is something that we will look into.
Okay, so I think this pretty much covers the demo. I think the debug goal is going to fail as well, right? Because
You're very faint right now. I can't hear you.
oh, okay. I think this pretty much covers the demo. I think debug goal would also fail because it also looks
Yeah,
for
it won't be able to
connectors.
select the container.
All right, no worries at all. So we have our application in our cluster up and running without doing anything, just plain old Java workflow. So as you can see how JKube simplified your Kubernetes experience by without you having to leave your Java ecosystem. So let me just go ahead and undeploy this. So let me check. Everything seems to be terminating now. All right. So I have everything cleaned up. I don't have anything running. So as you can see, JKube build your application, deployed it to Kubernetes, undeployed it as well. So do you think I missed anything, Mark?
Yeah, I think it's great. I think you showed almost everything. I think regarding Quarkus, we got everything covered. Now it would be a good time for people to ask questions, but I think that we are the only ones here, so